Today we are focusing on the industry automation, its element and scope. So what I mean to say with the topic is today we are going to discuss much about some new terminologies. Might you have heard about some of them or they might be new to you. If we think about right now, I have seen that automation is sometimes confused with mechanization, but the two are quite distinct. Now, right now, I have got that information from various my other colleagues, and what I'm actually, and I'm discussing, I'm finding them. Because the mechanization is simply involving the use of machines instead of human physical effort, that is muscle power, and to accomplish a given task. So if we think about a true automation, it means the performance of an operation by an automatic control equipment capable of self-regulation. So self-regulation is a main important part of any automatic system. So if we think about a machine or a system of machines that achieve automatic control and self-regulation, that can be only possible through a feedback. So most probably you will find most of the automation system is a kind of feedback system. There might be an open loop control system, but this is a kind of system that uses sensors, controllers, and various other things. So let us start and begin with the new topic. Yes, let me just minimize this window. Please put your please stop your sharing videos. Okay, thank you. Yeah. So this is about me presenting in front of you all about today's topic. Let's see. So today we are going to discuss about the industrial automation, process control, industrial control system. As I said, there are some new terms. Need of industry automation, elements of automation, careers and scope for the new, those are new to the field or they are right now working in the field, what they can expect from it. And also we are launching our new industry automation foundation courses. So you will be it will be quite interesting series. So I hope you will like it, enjoy it at the end. So just go through it. So if you think about it, what is industrial automation? Right now, if you go by definition, where the very first point says industrial automation is the use of control devices such as PC, PLC, PACs, etc. This kind of systems are there right now. There's a control industrial process and by machineries. And what we do by reducing the human intervention. So mostly, if you think about industrial automation, yes, there comes in term reducing in human effort. So that is what reducing in human intervention, and possibly it is just we are replacing the human, not only the human intervention from the various possible processes, but also reducing the dangers from humans there, which we are actually making them to suffer in specific any nuclear plant or something like that. If we are automating certain kind of plants, it actually helps to maintain the safety to at utmost level. Also, this is what we call industrial automation is kind of closely linked with the control engineering. So what exactly I mean to say is that industrial automation is kind of automating the process, reducing the human intervention to optimize the process to maximize the output and minimize or utilize our resources in very well managed and efficient manner. So as I have mentioned here, some of the systems you can see in the images also, there are PLC, PCs, PACs. What are they? Actually, they are kind of control devices. You might have heard about certain called PLCs. Most of when I talk to various students, even very industrial personals, they have heard about PLCs. They know what PLC is. But if you go again ahead of PLC, what are the limitations of PLC? If you know, if you have done research about it, you will find there are certain limitations with the PLCs. And to overcome that, we come up with the IPCs or industrial grade PLCs, industrial called PCs, industrial grade PCs. They not only just allow us to work at with the PLC, just like in PLC, but also allow us with some extra functionalities. Right now, if you think about what is the latest trend that is going on in the industrial automation is a PAC system. What is a PAC? Generally, PAC is an abbreviated word of industrial process programmable automation controller. So if you think about what programmable automation controllers are, so it's a kind of system in which you will find it's a generally multifunction industry controller, and which actually simultaneously monitor and control digital, analog, serial input outputs devices. Not only that, at the multiple resources, not from only the single platform, and while supporting multiple built-in communication protocols and data acquisition capabilities. So PACs are quite, we can say, the system which is combining all the facilities that we are actually trying to fabricate using PLCs, IPCs, and all those things. So PACs are the latest trend. We don't know where it will take us to, but this is right now we are with the PACs in the system of this industry, in the industrial automation area. So these are the latest trend right now in upcoming in this industrial automation. So certain kind of controllers we can see in this industrial automation, and what the major aim of this industrial automation is to just enhance the productivity, reduce the cost, impact of the human on the atmosphere. That is the major concern. Eco-friendly systems has to be done, has to be made. Our process should be much more eco-friendly operated. So, and safety is the first and foremost part. What about the industry automation? What kind of engineering sectors it includes? Yes, it's an engineering sector. It is not, if we can't say it's apart from something to dedicated to specific engineering field. If we go by a statement, the second point in my presentation, where you can find industrial automation is a multidisciplinary subject that requires knowledge and expertise from various engineering sectors. So what are those? I have clearly mentioned electrical, electronic, chemical, mechanical, communication, process, and software engineering. So you might understand it's not the game of one engineer. It's not always that the one engineer is above than other. Just like most of them things that in engineering, there are certain fields in which you can earn more, which you can earn less. Earning is a different point perspective, but I would say what is the participation of various engineering disciplines in our automation systems is a huge. Right now, there are some of them I have mentioned in my presentation, because after doing huge research, I have found they are the most proactive field of engineering, which are actually taking active part in the making this automation industry automation of an industry possible to a great extent, not only by making it possible, but maintenance the other part. That is what the I would say the most earning part of automation sector is, that is also made possible because of these sectors. So I hope you're clear with this new term. I think I must have redefined the definition of industrial automation for you. So that is what you can just have from it. And just go to the next slide. So what are the examples of industrial automation system? Where you can find it? You can find it in the automobile industry. You can find it in aviation sector. You can find in process textile industry, in mills, where you can in healthcare sector, in railway sector, in power distribution and generation sector, even in various, I would say, manufacturing industries, and many more. So you might have understand the wide range of application of industrial automation makes the field so complicated to understand at a one perspective. There need a broader sense to understand it and to apply the knowledge, and to how you should gain, or I would say the experience needs a quite variety of experience you gain while working in this field. So it's quite interesting to work as an automation engineer when you come to this field. I hope you will enjoy. If you just, once again, if you get a chance, I see that you must grab that chance and become an automation engineer. You'll surely enjoy the engineering. You will see the engineering has been redefined in many ways. Before we go much into the system called automation and various other things, what is a much more, and the basic thing is what we call the process control. There are various, there are theories, there are lots of theories of industrial automation, or I would say this process control. But I'm not making this much complicated and much more, I would say there's, okay, let me, couldn't see, okay. Is everyone is able to see my presentation? Please let me know.
Yes, yes.
Okay, okay, fine. Thank you. Please disconnect and connect your, once again, who is this? Kalpesh, please kindly disconnect yourself and once again join our session. I will just accept your request. Yeah, thank you. So what about process control? So there are quite a number of theories you will search about it. what the process control is, but I will just describe it in very easiest manner. I would try it. If you think in a one way, process control is kind of a active changing of the process based on the results of the process monitoring. For example, if you're monitoring certain process and if you find there is some need of change, so once you monitor the process, once the process monitoring tool have detected some out of control kind of situation, for example, so that person responsible for the process makes a change to bring the process back into the control. That's what the basic process control methods, or what to say the process control is. So here, what I'm trying to define, there are certain terminologies related to the process control. So we can generally define it as a manipulated variable. There are manipulated variable, disturbance to the process, and there's a control variable. So what exactly all this means is, whenever, if you go for a specific manipulate, just let me accept some of the participants. Yeah. Okay, so now if you think about the manipulated variable, what are they? So specifically, they can be a wall position, motor, speed or damper position or blade pitch, whatever it can be, depending on your process. And from that manipulated variable, certain process takes place, and that process actually controls, and we call them a control variable. So it can use a result. The control variables can be, they can be a temperature, they can be a level, position, pressure, pH, density, or we can call it as a moisture content, or weight and speed, and whatever. And there are many other, I would say, control variable. What disturbance does, as we know, when we are when I'm taking this webinar and someone is admitting at that time, that's a disturbance. Similarly, the disturbance to the process is a kind of similar thing. So we need to take care of the disturbance. We need to take the measurement of what amount of disturbance is, then we adjust the manipulated variable and we get the control variable. In this whole case, for each control variable, there is an associated manipulated variable. So we can say the control system must adjust the manipulated variable so the desired value, or we can say a set point of a control variable, is maintained despite of any disturbance. So that is how we can define them in this way. So yeah, I hope that is far more enough. So what are the examples of this process? What are the examples of process control? Let's move ahead and let's see some of them. So these are some of the examples of process control. Here you can see there is a nuclear power plant control rods. So there is a whole process that is defined in my animation. You can see over there. So over here you can see the process when we need to control the production of power, or need to control the reactor. The control rod has to be inserted into the system to maintain the output of a system. So the process needs some sensors and all those things. So it's kind of an example. To give you an example, if you want to just go for a nuclear power plant in controlling rod, to specifically to control rod automation, you can think about there is an immense amount of process and data are necessary to automate the system. In spite of automation, we can just think about the process control. So that is a method, a way to control the process. And if you think about my second example is about RO desalination. So in this case, you can just think of what the RO desalination process is. Even you are making actually desalinating the water to making it more purified way, in purified form that you can drink, a drinkable form of water. Here, if you want to monitor the health of, for example, membrane of RO membrane. So in this case, you can use various sensors, transmitters. Even you can use some flow control to understand what exactly the health status of my RO membrane is, and in that way you can actually make the process happen. So actually these are nothing but a kind of process you define. It's kind of process, how to control the process that is defining in this examples. I would say the most you would love to have, you will love to see the second most example that I have kept over here. That is an ice cream production process. So actually when you are dealing with the process control of any system, any mechanism over here, so you will find here there are certain stages in process. So for this case, in my case, there is an ice cream manufacturing production process. So here there are certain activities, there are certain process control points. So in this case, there are just stages like weighing or mixing, pasteurization, cooling, freezing and aeration, packaging, seal, label, refrigerant. So there are certain stages and the activities mentioned according to them, and the process control points, or we can see some checkpoints, has been there. They can be done manually. If you have some sensors, you can just mount sensors on them, transmitters, controllers on them, and we can just monitor, we can maintain this by maintaining the checkpoints. This can be done if it is done with the help of some automated controller. We call the industrial automation of processes. So that comes the process automation, and another term which we are knowing to it. Another, that's what's a basic example if we call about in the process control. I hope that has made you very much understand what process control is and what are the examples of process control. So I will be moving to my second slide. There's something, a new term called industrial control system. Now, what exactly it means? So if you go by definition to an industrial control, okay, I will write down. Industrial control system. So ICS is actually a collective term. It's not a specific machine, or it's not a specific thing. It's a kind of environment. It actually uses the control system and instruments associated with it, which can be various devices, system, networks, control that is used to operate and automate industrial process. In this case, if you think about what are there several types of industry control systems. So in this case, you can think about SCADA system or DCS. And both of them, if you want to create and implement this ICS environment, so you can think of an hybrid system, which is made up from DCS and SCADA. Actually, it includes both the attributes of both the system. And in this case, I have actually also given, I will just give you an example in the upcoming slide. But if you think before we go to what exactly ICS, what are the components of ICS? So that will give you a much idea what actually this term is coined for. So most of you may not be aware of certain kind of things, but these are the new terms that are coming to this new age of industry automation. So you must be aware of right now. You must, after this, you might be searching for this. You might search for this, and this is a good, actually a new type of, I would say, environment or establishment of a control philosophy. So that's the industrial control system, and it includes IT and OT sectors. Actually, what exactly it means, generally, the IT, if you think about what IT sectors take care of, here it's actually here it takes about the information technology. If we know about it actually, and we know what information technology does. It actually provides us various tools of software analysis. First of all, the data management, the cloud computing, and all those are the parts of IT sector. And what exactly OT means? OT means the operation technology. So operation technology means exactly what it includes. There are variables include like hardware, softwares, system monitoring and control physical devices in the field. So if you are thinking about the field, think about the OT. If you're thinking about the soft computing, cloud computing, think about the IT. So these fields are integrated into it. PLCs are the one of the major controller that is used. There are certain RTUs. Actually, RTU is nothing but they are microprocessor or microcontroller based small controllers we can think about. There are some control loops. They can be made up of some new PID controllers or whatever. There will be certain software or certain kind of hardware can be there. Yeah, and there are human machine interface, then HMI. It's just as we can see a smaller version of SCADA, and there are remote diagnostic and maintenance. Control servers, mostly control servers, they actually, it's a host that DCS or PLC supervisory control software, and it communicates with a lower level control device. I will just show you in an upcoming image. SCADA is again, we can call it as a master terminal unit MTU. There are some intelligent electronic devices. We can say the smart devices, actually intelligent electronic devices, they are the smart devices capable of acquiring data, communicating with other devices, and performing local processing and control. So that is what associated with, we can call it that intelligent electronic devices. There are data historians. So data historians are nothing but they are the servers providing a necessary data base for logging and all the necessary purpose. So yeah. So this is all about, we can call it as a data history. It will be much more clear with the upcoming new image. You will be actually seeing this all terms in one image. Most of the automation engineers have seen but not had heard about this term. So let me just change my slide. So you can see over here, there are certain, this is all about the production network, supervisory and control networks over here. There are some remote terminal units here. You can see the workstation, all are collecting data, and this is all going to the data historians, or you can say the SCADA servers, and this is going back to this console. So here we can see it is not a new to an automation engineer at this point who is working with the latest technology. They have heard, they have seen this thing, but exactly they might not have come across this term. So this is all is we can call it, this is you can just coin it as an industrial control system. So this is all inside it. Here you can see all those systems which I mentioned in my previous slide actually contributing to this environment. So it's not a device which is made up, it's not ICS, it's not a device, it's an environment which is created with the help of these devices to make our system more intelligent and more efficient. And safety is the another process, another term. Yeah. So after going through various terms, I might have, you might remember, I have not discussed one of my term I remember right now after coming to need of automation is the Industry 4.0. You might heard about that. It's a kind of term. Industry 4.0 is right now the latest. We can call it as a certain kind of, many us are hearing this term, but might not be clear what exactly Industry 4.0 is. So exactly, if you think about what Industrial 4.0, it's nothing but an unified concept, just like an ICS concept was. There are many IoT things, embedded system, and many cyber physical systems that are actually integrated in an ecosystem. And they are just making that integration, and we are coming up with a new concept called industry automation. It is more safe. It's a kind of system, industry automation, not a kind of controller. The controller will make Industry 4.0 possible. So I hope that I made that term clear. I just remember right now just taking this presentation. So it is not right now not concerned with this need of industry automation, but this is what Industry 4.0 means. Now, if you think about what exactly the need of industry automation, why we need to automate a system, why not we go through the conventional way? First and the foremost thing is, now we can see today's situation, the societies are not smaller. 100 years back, the situation was not like that. The demand was not up till that. Right now, we can say there is huge, there is a population boom. You can't actually, we are unable to control the population. We have to accept that. So if we are unable to do that, we need to compensate in other ways. If we try to work in the same manner and same fashion, no matter how hard we try, but we won't be able to achieve efficient and effective way of generating a quality product. That is the form, and that is what we say that today the industries are prioritizing. They need the quantity, they need the quality. They can't compromise between them, between these two things. They need quality plus quantity. So to maintain that, automation comes in handy. So if you think about initial industrial process, they were done with the help of workers. And what workers has? He has eyes, hands, and brain. He uses that to automate a system. So in this case, what we use in contemporary today's situation with the help of industrial automation, we use sensors as an eye, actual computational unit, that might be PLC, PACs, or PLs, IPCs, any one of them, as a brain. So you might have got that relation what I'm trying to create. So we are actually working with the same control, with the same philosophy. There is no change in the process control or a kind of, we are not changing the kind of how to control a process or everything. We are not changing that. Basics are the same. The only thing that has changed right now is instead of using a man, we are using machine. So right now, that is what the fundamental, if you think about why we are motivated for that, as I said, production increases, first of all. So what does how the production increases, very thing is, that if we, by reducing the human, actually the speed can be compensated. Humans are not that speedy as the machines are. Again, cost reduction. the very, I would say this term, you might say that I'm sounding more ridiculous, but that is very true to the thing. Cost reduction is mainly due to the reduction of labor. It is not due to any other fact. It is because of the reduction of labor. This is, yes, it might sound very weird that we are actually manufacturing engineers and we are saying we need to reduce the labor. It means we need to reduce the labor from the point of view of doing this semi-skilled and unskilled work. We need more skillful engineers right now in today's scenario and situation. So that will actually help us to maximize our chance to move towards a more effective and efficient methods and process of generate or manufacturing process. Well, we'll move to the next point, that is the improvement of the product quality, and that is happening. Improvement of raw material utilization. So that is what the foremost thing. So that reduces the material loss. So in a previous way, if you are doing manually something and if something goes wrong, it will create a huge disruption in the chain of supply. So, and also it will create a great loss, and raw material will be utilized in very I would say in very feasible, not in very feasible manner. So to make the utilization of raw material in more efficient manner and feasible manner, it actually automation helps us. And the first and I would say the primary point is the reduction of energy consumption. So that is what today's challenge is. We are actually struggling with this energy consumption term. We are actually trying to make machines more effective, more efficient. And efficiency means then whatever the output we get, it should take less input for that. It's very simple and a straight equation, but that equation is straight and simple, but concepts might be more tricky to make it happen. Here is some example. You can see an image. Here there are certain sensors which is making the process automated. So instead of having human intervention, we can make the process work as a self-regulated process. We can make the process as a self-regulated, and it can work up till we allow it to work. So again, don't think that industrial automation is actually taking the work from the hands of man and we're allowing it to laborers and some of the industry persons who are actually going for more profit, not allowing man to work or not allowing new workforce to come into this sector. Actually, we are now dealing with the problem of more unskilled engineers. That is what the main thing is. So we need to just upgrade our college courses, syllabus, and various things. We need to upgrade our method of teachings, and all those things will come handy to go through this process. We'll move to the next slide. So now coming after this need of automation, we'll move to what are the elements of automated system. Now to define an element of an automated system, you might come to with the very first, you might come with the terms called PLC, DCS, SCADA, and various other things, but they are not the elements, they are the components of automated system. What elements of automation is, we think about automated system, they can be categorized into three basic ways. There's a power, there's a program of instruction, there is a control system. Now it might look very kind of different absurd words to hear, but let me explain, give me some time to explain it. So now in this case, if you think about what power, program, control, and process, all this is, actually power is a very basic need. If you think in the form of electrical energy, it is first and the foremost thing required to run any process. Power can be in terms, not only in electrical terms, it can be in terms of mechanical energy, thermal energy, chemical energy, it can be anything to run a process. That's why in any automated system, if you want to run a process, you need a power. Then comes a program of instruction. What it does mean? There is always a control system that is actually installed in my, I would say, in a process, specifically in an automated system. Now to control that process with the help of control system, that controller needs some instruction, program instructions. So the action performed by an automated process that is defined under this automated instruction. So this is what we can call it, define it, this is a program instruction. And again, there is a control system. What control system is? It's just like a control element for automated system executes the program of instruction. So that's easy. I hope I might have coined those certain terms, and you might have come across this new this concept of there are certain elements, and these elements are common no matter what the process is, no matter what automated system you're dealing with. But you will find these three terms are common. You can actually categorize your system into these three terms. I will not go much into it. There are various, you can read much more about them in our internet. Now we'll talk about for our engineers, those are working, for those who are not, or those who want to, and those who are in a academic part and they want to tell their students what is the scope right now, what is the current situation. Rather than the scope, let me talk about the current situation of our industries. Right now, most of the industries are heading toward the automation part. No one wants to miss this, because of the only reason the productivity increases, quality increases, and the performance of the system increases, profit increases. That is the major part, profit. Yeah, I might sound like a money-oriented person, but that is what the need thing to run the society. You need economic. And where does economic come from? This comes from industries in every nation. So to run industry smoothly, efficiently, automation is the first and foremost thing. So if we see with the progress of this automation, there are quite challenges in this society and also benefits in this society. First of all, if we talk about the benefits, it actually reduces the cost, improve output, both in terms of quality and quantity, as I said. And if you properly apply it, you can free your workers from unpleasant, tedious, and hazardous job. So in this case, what it suggests, actually it is helpful from one perspective, from one point. You can see this automation is actually very handy and very useful in our today's scenario. And apart from that, if you see this all benefits, yeah, these are all the benefits, but increased automation has also caused a serious problem for the workers that are actually working in manufacturing plant nowadays. Because at a certain point, if you think about mills and textile mills and various mills that require thousands of employees to make those things happen. Nowadays, only few hundreds of workers are required in the presence of automated systems. Yes, the system productivity has increased, efficiency has increased, quality has increased, but jobs are decreased. But right now, that is not an important point if you think directly in one way. Jobs have not decreased. There is a new, I would say, evolution in this form. There is not, the employment has evoluted. There is evolution. There is evolution in this employment. You will find jobs have evoluted, and there is right now no scope for semi-skilled workers. You need more skillful candidates to work under today's industrial environment. If you want to earn more, if you want to earn decent, if you want to sustain yourself, just you're not have big dreams, nothing else, then also industrial automation will never leave your hands. At least you will need to gain some skill to understand industrial automation, and that is very much important in today's scenario. Also, with the advancement of industrial automation, you would see will not be a demand yet, but become the necessity. With this advancement, whatever you're seeing right now in industrial automation industries, that automation will not be in the demand. It is not the demand of industry that they need to automate because it is more profitable and all those things. It will become necessity in future. Because why? The societies are growing larger, and to satisfy their demand, larger societies, this automation will become necessity of every industry, or they can't grow, or they can't sustain their own workers. All those things, therefore, it is needed time. This is a time for every engineer to upgrade their knowledge, skill, and hence that will help to contribute them to society in a greater way. Think about a contributor. You can be a bigger contributor with this learning, these new skills, and acquiring this new knowledge. I hope that will help you more again in future. Let's move ahead to the next slide. So what are the opportunities? You can actually share with your students or your colleagues. Is that there are various opportunities in this automation industry. So if you think about where are these opportunities are. So these are certain, I have listed some of the companies, I would say some of the sectors where you will find much more, and they are the much more growing and demanding sectors. There are certain OEM and SPM manufacturers. What I mean by them is they are original engineering manufacturers, or they could say special purpose machine manufacturers. They're actually not generating an original machines. They're actually using some controllers and creating a kind of system that is selling to other. So, but that is what the booming sector is right now. Many OEMs and SPM manufacturers are there in industry, in a market right now. You will find there are also various jobs into them. There is a job into the system integrator and product channel partner. I'm from the system integrator and product channel partner. I'm working over there. There are various parent product companies, automation solution companies, manufacturing companies, process industries, and IT industries. Yes, IT industries is also coming under the automation, not the automation of a product, but report generation, cloud computing, I would say data handling, security, cyber security is again a new term to it. But these all things are very much important to today's growing industry automation. I would say the automation that is growing in our industries. Whatever you might have your basic current domain, I don't know, and that is not of concern right now. If you know some about hardware and software, you will find yours know about some hardware and software automation. You will be find some of the opportunities in this many industries. And if you're looking to brush up your technical skills, especially embedded system, electrical engineering, basic programming skills, I would recommend, actually we at HIMEC Academy, not only focusing on doing and giving the basic training, we also providing them to the new upcoming hands-on to the new upcoming controllers and the manufacturing processes. So they come to know about various new things. And for that, what we are doing, we are launching a new course actually with this. That is what we say, you can take your first step in this career. If you want, you are really interested, we are actually launching a foundation course, which will be a 5-day course. It will have 5 webinars and there is 1 certificate. So that will help you to upgrade not only your skills, but you can boost your resumes if you are finding a job in this sector. So what we are actually focusing in this, you will find we are actually trying to improve. There are more terms right now. Some of the terms that are included in this presentation are very limited. Even I have kept them to a very limited level because of the time boundness. I can't keep a lecture of 2 or 3 hours right now in this case, because I know most of you will bored and they will leave this webinar. But this is what my focus is. We are actually planning to go to more than 2 hours of webinar, having some doubt solving sessions. We are also not only giving them some new terminology, we'll not only teach them some theories, but we also we'll also make them how to work with PLC, wiring schemes, what is tagging scheme, how to develop a logic in PLC, what are the new methods, what are the products that is available in this leading Siemens brand, other than Siemens brand, what are the other brands that are providing this all thing. There are 2 batches, so we are planning for that, and only 25 seats, we are limited to that. So if you want to know what you will get with this course, you can just read through it. There's a very basic concept. We'll start from very basic. If you are not aware of anything, that no problem, this is a course for you. And if you we'll be focusing on every individual students, because that is what the important thing. We are keeping a limited number of seats. We are demonstrate some upload download as in actual PLC. You will actually have this demonstration in front of you. Will be also provide you some facilities to later this lockdown and various this all thing goes off, will allow you to come at our training facility to test this all by your own hand, by your own self. Testing and development of logic, real-time logic troubleshooting, and at the end you will be interacting with various faculty experts in this field, and there are some industry application examples. We're practicing on that. So that will actually help you to grow, and at the end of this course you can actually think that you will be able to understand there are various kind of actually automation process. I have just, you will understand how to think about this discrete and analog automation, what is input-output concept, what are different industrial communication protocol. That is what the major thing is in nowadays, today's scenario. Apart from that, you will understand how to, what's the wiring it's actually the PLC. That was my first webinar was based on, but that is all we are, we'll just complete all this thing in this webinar also. We'll cover this thing. Develop a PLC programs, automatic system, diagnosis, which is the most important, and make correction in PLC program, and you will have various ideas available in PLCs. So we are actually dealing with this course, and actually this is a certified course, so we are actually charging for it. It's a paid-based course, and there will be various documents shared with you. You will be also given some benefits of registering to this course. We'll be allowing you to come to our facility after the situation gets normal. You can able to come and practice some of the logic that we will learn to develop in this webinar sessions. At the end, you are going to get the certificate, so that is really helpful. But apart from that, these all things, I hope you'll be able to get what I'm trying to say and why it is important. If you think it is important for you, and you must go for it, because it's starting from very basic. You will understand there will be very thorough discussions for it. I will actually discussing in various manner, and also understanding various things which you are actually going to see in coming industries, or you are unaware of those things. So you will just cover all those things. Apart from that, if you have questions to how to enroll in this in this course, so I have just put in small video. I will say, you can just type on Google, open Google, type HiMac on it, and you can directly go to the Google, and you can just see, you can click on the training over here, and as soon as you click on the training, just scroll it down, and you will find there is a small tab at the bottom written with the training. You can click on it, and just scroll it down once again down, and you will find the information for the webinar over there, and you will get all the latest information over there, and also some key points and what are the outcomes of the courses. You will find the contact number over here. So this is all about myself, and you can actually contact me at that number. You can, if you wish to pay, if you wish to enroll, you can directly come to this side. It is actually completely secure. No forgery will happen in this case. You'll need to name, address, email, your phone number, and you can pay with your Visa, MasterCard, or any of them. You will get an acknowledge message. I will also receive your details. So your details will be kept confidential. You will be receiving a certificate at the end of the course. So don't worry about that. And we'll also give you a support after that. To come at our academy and enjoy the actual hands-on experience. Based on, there will be no charge for that. We'll have 1 free sessions for you at our HiMac Academy. Apart from that, I hope you have got an idea. So if you have any question for today's session, you can ask me, or else we might conclude. I hope that is fair enough for you. You can just write your question or unmute yourself in this case, that would be fine for you. So please kindly come up with your questions, or you can just mail me on the later on. You might have our mail IDs, or else we'll be sharing you at the end of this presentation. Yeah, anyone, if had a doubt, you can ask me. Yeah. So I will unmute you. Anyone has a doubt, let me know. Okay. Okay. Is someone talking? Let me know. Okay, fine. You can raise your hands if you know. Okay, no issues. No issues. I will just conclude the session. I think you're all set with it. And I hope I have tried to improve your knowledge in this field of industry automation, redefining automation, I would say. And this is our address. You can actually directly mail me at training@himac.co.in. And this is our address. You may visit to it. And yeah, there are certain chat. I will just say. Yes, Neeraj Singhala, I will provide you this recording. We also have the YouTube channel, so don't worry. You can go to our YouTube channel directly by typing HiMac on the YouTube. You can directly go to our YouTube channel and access. Even if you don't find our videos, if you find some problem, you can directly contact me or you can mail me. You can also have my number. You can go to our website to as I've shown in this small video. You can directly visit to a website and you can just get that recording from there. Yeah, I hope it is very everything is clear, and thank you for your yeah attendance. Okay, thank you everyone. We'll just stop sharing this session, and thank you all of you.